We're skipping over the next four entries in Edit Mode's the Mesh menu. These are Weights, which is primarily used to fine-control armature animation. Set Attribute, which is used when assigning a value to a specific element within a mesh. The use of such a value is beyond the scope of these videos. Sort Elements, which is used to control the order in which Blender processes the elements of a mesh. Show Hide. We are skipping this entry simply because we have already seen how to use the keyboard shortcut options for hiding and showing various objects in our scene. When in Edit Mode, these options allow us to hide and display groups of elements within a mesh. Now we come to the main topic of this video, the Cleanup submenu. This submenu features several options designed to tidy up geometry, remove excess elements, and ensure a cleaner, more manageable mesh. Delete Loose removes any elements in the selected group that are not connected to a face. In this example, we start with a monkey head mesh, where we have previously removed some elements, leaving vertices and edges that are not attached to the main area. Performing Delete Loose removes those detached elements. This operation has a Last Op panel where we can specify which loose elements are to be removed. Vertices and edges are selected by default, but we can also delete unattached faces. Decimate Geometry removes a proportion of the selected elements in a mesh while retaining as much as possible the original shape of the mesh. The Last Op panel allows us to further control how elements are removed. The ratio value determines what percentage is removed. This can range from 1, which is the default value, down to 0. 1 has no effect on the mesh, while 0 removes almost all elements. The Vertex Group checkbox is really only relevant if the selected part of the mesh contains within it a vertex group. A vertex group is a named set of vertices and was discussed back in video 36. Here we've defined the vertices of Suzanne's right eye as a separate vertex group. When vertex group is selected, this causes the decimate operation to deal only with the vector group in the selection to be decimated and ignore the remainder of the selection. Only one vertex group can be included in the selection. With vertex group selected, weight value controls exactly how decimation of the group operates, but there is no obvious relationship between this value and the result. Selecting invert when vertex group is also selected causes decimation to work on all but the vertex group. Before we begin to use decimate geometry on Suzanne, her mesh is perfectly symmetrical along the x-axis, but as we reduce the number of faces, we can see that this is no longer true. By checking the Symmetry checkbox and selecting the X button, Blender will ensure that symmetry remains as the face count reduces. Degenerate Dissolve eliminates short edges. Exactly how short the edges must be is set in the Last Op panel's Merge Distance field. Limited Dissolve is an option we have already covered since it also appears in the pop-up menu that appears when we press X to delete the current selection. See video 39. This operation removes edges that exist within a flat area. For example, in the trivial result shown here, the extra faces on the sides of a cube are eliminated because they lie on a flat or coplanar area. The Last Op panel gives us further options for controlling this operation. Max Angle allows us to merge faces that are not coplanar. This value specifies the maximum angle that exists between faces that may still be merged. All boundaries dissolves vertices so that adjacent faces never share more than a single edge. Delimit stops merges where the option selected here differs between the faces that would normally be merged. For example, we might stop mergers between faces that have been assigned different materials. When moving vertices in a mesh, it is quite easy to create a face which is not flat, as we can see here in this grid. Generally, it's not a good idea to have non-planar faces, so we can use Make Planar Faces to flatten this type of face. In the last op panel, Factor determines the degree to which flattening occurs, with 0 being no flattening and 1 being maximum flattening. Iterations specifies how many times the factor value should be applied. We may need to increase this value significantly to achieve a perfectly flat face, but that runs the risk of distorting other elements. Split non-planar faces uses the opposite approach to the previous option and will split a non-planar face into two separate planar faces. In the last op panel, max angle defines the minimum angle at which the split will happen. If the angle created within the non-planar face is less than this, then the split will not occur. Split concave faces will split a concave-shaped face into separate faces, as we can see in this simple example. Merge by distance merges vertices that are within a given distance of each other. In the last op panel, merge distance specifies the maximum distance between vertices at which merging can take place. Normally, the vertices will merge at the location of the last vertex to be selected. When centroid merge is activated, the resulting vertex is at the center of the vertices being merged. When unselected is checked, selected vertices can merge with unselected vertices within the specified distance. Sharp edges marks a newly created edge as sharp under some circumstances if the vertices being merged have custom split normals. Exactly when this occurs is not at all obvious. Fill holes adds faces to gaps in the selected part of a mesh. In the last op panel, we have a sides field, which specifies the maximum number of sides a hole can have if it is to be filled. Holes with more than this number of sides are not filled. However, setting the value to 0 will fill all holes. The final entry in Edit Mode's Mesh menu is Delete. This offers exactly the same options we get when pressing the X or Delete keys. These options were covered in previous videos. The dissolve options were discussed explicitly in video 39.